Finding volumes with disk method and shell method is what we use most often, but there's a third way called using cross sections. That's a different way. It does appear quite frequently on the AP test as well. So we got to make sure we kind of get this down and practice it. It's a little bit tougher to visualize what's going on here because the shape is kind of like our bounded area is kind of like on our graph and it's going inside the paper or coming up out of the paper there. So it's a little tough to visualize just from your 2D two-dimensional graph. But I do have these nice steps. If we just follow these nice steps, even on the AP test, it's always been pretty straightforward and we're going to get these things right there. But the cross section is essentially, there's a few pictures in our book and our homework there is they'll give us that, hey, we're going to have square cross sections. So we're going to take this square and we're going to radiate it throughout this shape depending on what the curves are. And we're going to create a three-dimensional shape. Or we have equilateral triangles for a cross section. So we have that radiate throughout our shape and it can get bigger, get larger depending on what the curve is. And we can create a three-dimensional shape. Or we can have this little like lemon wedge, semicircle cross sections where we create these shapes there. So I do have this little thing here. All right, you see this shape and it's got all these other different shapes on there. So you can use square cross sections, you can use rectangle cross sections, you can flip it over, you can use semicircular cross sections, but you could use, so it creates this three-dimensional shape. And then the curves are from the actual equation. So it depends on what those equations are. The rectangles will get larger and larger and larger, and then smaller and smaller and smaller. And so that's what we talk about when we're going to use cross sections. So to me, it's a little bit tougher to visualize what the shape is just by looking at your thing because your shape is actually going like inside or outside, coming up out of that paper right there. But I do know if we follow these steps, we're always going to get these things right there. So if I want to find the form using cross sections, here's what you're going to do. You're going to draw your bounded area like we always do. You're going to draw a segment perpendicular to the given axis. You're always told perpendicular to the x-axis or the y-axis. And once you're told perpendicular to the x-axis or the y-axis, that's what determines whether it's going to be a dx problem or a dy problem. So automatically, if I see x-axis or y-axis, that means it's going to be a dx problem or a dy problem based off of that. And you're going to find the length of that s. And that's the same thinking that we use when we did our shell method to find the h, the height of the rectangle. When your s is drawn up and down, you're going to go top y minus the bottom y. When your s is drawn sideways, you're going to go right x minus the left x. So the same type of thinking there, you're going to find the length of that. And you do those first four steps, no matter what they tell us the cross-section shape is. And then they're going to tell us area, they're going to tell us like rectangles or equilateral triangles or squares or something like that. And then that's when we do this last step. So you do those first four steps no matter what your cross-section shape is. And in your last step, you're going to integrate the area of your cross-section shape. So here's a typical problem. And we'll do a few different scenarios. We'll even add to this, have this handout linked to you. So you just kind of make some notes for yourself on there. But it gives us the volume of a solid. We got a couple equations, cross sections perpendicular to the x-axis. So the instant I see perpendicular to the x-axis, that tells me this is going to be a dx problem, which is pretty nice because all my equations is already in terms of x's there, so I don't have to worry about changing anything. And so what you do is you graph both of those functions, use your graphing calculator, I don't care, but just get that on your paper. And then maybe just what we could do to find the intersection points there is set the two equations equal to each other. If you set the two equations equal to each other, you can get those intersection points there. Sometimes if they're nice numbers on the graphing calculator, you can just hit that trace button. If it looks like it's at 2, type in x equals 2 and see if that points on both the equations right there. But you got your graph. So there's my bounded area with it labeled. And then it tells me draw a line segment perpendicular to that x-axis there. So I draw on that line segment, that S. We'll talk about what that represents in a second. And then, so I already got the first few steps down. Got my area, got my perpendicular to the x-axis, got my S in there, and then I already know it's going to be a dx problem. Now, when I find the length of that S, it's up and down, just like the height of that rectangle. I'm going to go top y minus the bottom y. So there I find the length of that S, and that's what we're going to use in our formulas right there. Now, again, you do those first four steps. And then the next step, the last step, is the only thing that's going to change depending on whether we're going to do squares, equilateral triangles, semicircles, rectangles, whatever there. But the things that I've seen the most is like squares, rectangles, equilateral triangles, and semicircles on the actual AP test one there. One year we'll get it when we do our review. They gave us an isosceles right triangle. We just had to use like 1/2 base times height. Now, what this S represents is one side of your cross-section shape. It's the base of your cross-section shape. So if your cross-sections, if they give us the squares, this is representative of one side of that square. Okay, and remember, though, based on this shape, those squares will have variables in, but they'll have variables in because the squares will keep getting larger and larger, and then smaller and smaller, and will create this three-dimensional shape, right? So that's one side of your square. If they give us we have equilateral triangles, that has to be representative of one side of that equilateral triangle. If they tell us that we have rectangle cross sections, that means this is the base of the rectangle. They would have to tell us somehow what the height of the rectangle is. They'll just tell us the height is equal to 5. The height is like 5 times that, and we'll know what the base and the height of that rectangle is. Or if we do semicircles, this is the diameter of that semicircle, right? So if we just set up a few of these problems, here's the final step on these, is you integrate the area of your cross-section shape. So if you have squares, you integrate the area of a square. If you have equilateral triangles, you integrate the area of an equilateral triangle. If you have rectangles, you integrate the area of the rectangles. You integrate the area of that cross-section shape. And remember, the dx or the dy, that's going to add in that third dimension for us there. So for part A, I'm telling you, hey, we have cross-sections as squares. So you got to integrate the area of a square. The area formula for a square is just side squared. So you just take that side and you square it. When you set up your integral, you got to make sure x's and y's are here. Don't like integrate s squared, go s cubed over 3, and then decide you want to throw x's in there. That's not going to work, right? So you have to make sure you set up with the integral with just the x's and y's and stuff in there. And so when you integrate the s squared, and then it's a dx problem, so you got to go left to right, use the x's that take you across that bounded area. So you integrate that, you are going to need to multiply that all out, integrate it, plug in the top number, plug in the bottom number, you use that fundamental theorem of calculus, plug in your numbers, evaluate that definite integral. That's going to be the volume of that shape. All right, if they tell us we're going to do equilateral triangles, the area formula that you might have forgotten there, but the area formula for an equilateral triangle is radical 3 over 4s squared. Typically, I might give these to you on a testing situation there. Sometimes they give us to us on the AP test. Occasionally they'll throw something in there that they just expect you to know. So we'll just kind of make sure we know them. And then if I give them to you, that's just like an extra bonus there. But you integrate the area of an equilateral triangle, which is radical 3 over 4 times s squared. So since the radical 3 over 4 is a constant, you could pull that out in front, and then you integrate that s squared. Right now, sometimes in your homework, you got to do like a part A and a part B. If you already did this part in part A, you don't have to do it again. You can just say, hey, if this answer is like 1 over 10, then I'll just take radical 3 over 4 times 110. You should still show your setup, because a lot of times when I give you a test, I maybe only test you over one scenario or 2 scenarios, or the AP test will only be over 1 scenario. So you got to always make sure you show your setup. That's your justification. And if you already did a legwork on one part, you can just use that. You don't have to do that again. So if I gave you rectangles, this would be the base. You would integrate base times height, because that's the area of a rectangle. And this would be the base. I would have to tell you like the height is 5. So you would take this thing times 5, pull a 5 out in front of that integral, and just integrate that in between that -1 and that 2 right there. Let's do one final scenario together, and then we're done with these notes there. The one that sometimes people ask about the most are the semicircles. And so I just wanted to make sure I walk through that with you there. But the area form, so what you got to do, if I give you the cross sections are semicircles, you got to integrate the area of a semicircle. So I think we know the area of a circle is pi r squared. So a semicircle is just pi r squared divided by 2. That's what you got to integrate. Now, what you got to remember on the semicircles, this is not the r. The s on the semicircles problem, the s is always the diameter. The s is the diameter, which means the radius is always going to be the s divided by 2. Okay, so that's going to be this trinomial divided by 2. So when I integrate this, I'm supposed to integrate the pi r squared, right? So what I can do right away is I can pull out the pi over 2. I pulled out that pi over 2 because that's constant. I pulled out in front of the integral. I'm supposed to integrate the r squared, and the r is this s divided by 2. So that means I'm going to have like the trinomial squared divided by the 2 squared, which is 4, like that. So again, I have to integrate the area of a semicircle, which is pi r squared divided by 2, pulled out the pi over 2, and then the s is the diameter. So the radius that we need to square is that s divided by 2. So it's that. So I'm taking that thing there, and I need to square that for the r squared part. So I did the trinomial squared over the 2 squared, and then I could pull out this 4. I can make this a pi over 8, right? And then I have this trinomial squared. And so I always try to simplify it like that, especially if I already did part A. and I know that answer is equal to something, then I have this is my part A answer right there, this pi over 8. Now you're going to have a couple in the homework where it's not always going to end up being pi over 8 times that square answer right there. There's a couple weird things that pop up in the homework there that we're going to need to talk about, but that's my mindset. Pi r squared divided by 2, pull out the pi over 2, wherever the s is, divide that by 2, plug it in there and square it. If you have a fraction, square the top and the bottom. And then you always want to simplify that first, because then it makes that integral kind of easier to work with right there. But just kind of be prepared to do the cross sections. Typically, once you know how to do a few of them, you know how to do all of them. But sometimes I have people just kind of ignore that for a testing situation. They're really good at disc and shell, and then they just completely bomb the cross section stuff right there. So we got to make sure we follow those steps and practice those. That appears very, very, very frequently on the AP test. Like that disc method is always going to be on there, that type of stuff. And then this appears on there like a lot. Even if it's not in the free response, it'll be somewhere in that multiple choice there. So we got to make sure we practice those as well.